determine if the following series is convergent or divergent. So we got a series here, and we know that we denote this by an and goes from 3 through infinity. Since we have n square power, we just do the nth root test, okay, which is we find the limit of nth root of absolute an as n tends to infinity, and that limit comes out to be, let's say, L. If that is bigger than 1, then the series diverges. If this is less than 1, the series converges. If L equals 1, then this test fails. In our case, ANs are all positive. There is no negative 1 raised to n or n minus 1, so we don't need absolute value. So let's find the limit nth root of 4 1 plus 1 over n square. This is in fact, so it's 4 times, so we can separate into 2 inside. Limit n going to infinity of nth root of 4, and in this case is a n and n square and n, so it's pretty much like we have nth root and something, let's say x n square, that is x n square over n, and 1 n cancel, just n. So we got n square and nth root means just x raised to n. So that is in our case now then 1 plus 1 over n raised to n. So the nth root is gone. Now we want to evaluate this limit, okay, in fact this limit for both, and we know that when we take limit of, let's say a really high root 1000 of any number, it will be close to 1. If you take let's say, I don't know, 1 4 like that, any number here, you can even take decimal 0.1, it should be positive though, so this should be always pretty close to 1. And when this is infinity, so this is gonna go to 1 as n goes to infinity. Okay, so that part is taken care of now. And now we have another limit to worry about. Let's find that as well. So here limit n going to infinity of 1 plus 1 over n raised to n. Now this should remind you of something. This limit is the definition of, one of the definitions, by the way, of the number e raised to whatever that's 1, e. Okay, and when we have 1, that's e raised to 1. So this is gonna be just that, then 1 over n, so e raised to 1. So this limit is in fact e raised to 1, or just e, where e is about 2.72, that is bigger than 1. Then by the root test, the given series diverges because our limit is bigger than 1. Then by the root test, the series is divergent, or the series diverges. Final.